Assalamu alaikum, myself Seydou Sama and my roll number is 21TE09. Here you can see the lab report of Digital Signals Processing Lab. The objective of this lab is to first representation of discrete time digital signals into frequency domain via FFT. The second is resolution of spectrum. The third computations of magnitude, phase and power spectrum, and the fourth one is spectrum leaking and avoiding spectrum leaking. Here we are doing this lab by decimations in frequency method. In task 1, here you can see the input of this task 1 in which we are doing. First we are write a MATLAB program to validate the above given decimations, and then we program first divided the given signals into even and odd samples, and then we calculate the discrete Fourier transform for even and odd samples by separating, and then merge both of them using the formula of digital Fourier transform of even part, and HK is the discrete Fourier transform of all parts. Here you can see the output of this task 1 in second picture. In task 2, in which we are doing and check the above program for the signals given below: x1, x2 and x3, x4, x5, x6, x7 and x8, and we are observes and find any symmetric in frequency representation. Also match the calculated discrete Fourier transforms with standard functions of MATLAB. Here you can see the output of this task 2. In task 3, here you can see the source code of task 3 in which first we check the program in task 1 for the signals given below, and you can see the signals in this input code, and then we compare it with standard functions of x and y. Here you can see the output of this task 3, that we check task 1 for the signals in the task 3 and compare it with standard functions. In task 4, here you can see the source code of this task 4 in which we can further subdivide the above decimations up to 2 samples, and we calculate the digital Fourier transform of 2 samples. Then 2 samples of discrete Fourier transform added to form 4 samples, and then 2 and 4 samples discrete Fourier transform form 8 samples discrete Fourier transform, and so on. And now this 2 points decimation is called radix, fast Fourier transform of algorithms. And in source code we write a program by Fourier frequency transform that transform a given signal into its frequency representation using radix 2 algorithms. Here we put the signals into source code, and then output of this task 4. Now task 5, in task 5 you can see the source code of this task 5 in which we calculate the fast Fourier transform using your own functions for task 4 and task 4, and we compare it with the standard functions of calculating discrete Fourier transform for the following signals. Here you can see we are different signals w, x, y, z. The 4 signals we calculate the fast Fourier transform by using the functions that we use in task 4, and the both of these tasks here you can see the output of this both tasks. Thank you very much.